Hi everyone, for today's lesson we are going to be learning about how to translate trigonometric graphs, which means that we are now going to be introducing an h and a k into our function. And to translate graphs means that we are going to be shifting the graph left, right, up, and down, which is the reason for why we are introducing h and k. But before we get started, I would like you to please do this very quick warm-up. And for this warm-up, I would like you to please tell me if the equation represents a direct variation, an inverse variation, or neither. So that's what it's going to be. The first equation is x times y is equal to 5. For letter B, we have y divided by x is equal to 10. And for the third one, we have x plus y is equal to 15. So what I want you to do for each of these problems is I want you to solve for y, and based on the new equation, for solving after you solve for y, well, does that equation represent a direct variation, an inverse variation, or neither? So go ahead and pause the video and solve for y for each of these and come up with an answer. And when you have figured it out, go ahead and return. All right, so for letter A, hopefully you were able to divide both sides by x to get y alone. And when you do that, you end up with y is equal to 5 over x. And since x is in the denominator position, this represents an inverse variation. So this is an inverse variation because we're dividing by x. For the second one, I'm going to multiply both sides by x. And when you do that, you end up with y is equal to 10 times x. And since x is being multiplied, this is considered a direct variation. For letter C, I'm going to subtract x on both sides. And when you do that, you end up with y is equal to negative x plus 15. Now, since x is being added to, or negative x is being added to 15, that means that the y-intercept would be 15. And so this would be a situation that is neither. And that's because in direct variations, you need to have a y-intercept that is 0. So direct, inverse, and neither situations, that is the very first lesson that I taught you this semester, and it's going to come back on your final exam, so I just wanted to make sure that I talked about it, because it's been a little while. So anyways, this lesson, we're going to be talking about how to graph translated trigonometric graphs. And just a little bit of recall, in the last lesson, I showed you guys the equations y is equal to a times the sine of bx and y is equal to a times the cosine of bx, where a helped us to find the amplitude and b helped us to find the period. And whenever we created or identified our x values that we were going to use, they always went in increments of 2 pi divided by the absolute value of b times 1/4, 1/2, 3/4, and 1. So we always multiplied the period by 1/4, 1/2, 3/4, and 1. So now in 14.2, we will graph equations in the form of y equals a times the sine of b times x minus h plus k, and y equals a times the cosine of b times x minus h plus k. Notice that the only difference between the equations is now we're working with an h and a k. So here are some steps in order to graph these types of functions. Now the first thing you're going to do is you're going to identify your amplitude, you're going to identify your period, and then you're going to identify your horizontal shift and your vertical shift of the graph. So essentially, your first steps are to identify A, B, which your period is going to be based off of B, H, and K. So you want to identify those values first. Then what you're going to do is you're going to draw your horizontal line of y is equal to K, and that is called the axes of the graph. The axes of the graph is also known as your midline. This midline is going to be your dashed line. It's like kind of like you're shifting up and down the x-axis. So that's what y equals k is going to be. Then your third step is to find your 5 key points of y equals a times the sine of bx, or y equals a times the cosine of bx. What that means is that you're going to find your 5 key points. You're going to come up with another table of values without h and k. So you're not going to have h and k with your first table. But then you're going to find your final 5 points by translating horizontally h units and vertically k units. Your translation vector is going to be hk. So whatever hk is, they're going to ask you what's your translation vector. You're simply going to write h and k. Now remember, inside of your parentheses, that your h is always going to be the opposite of what you see. Whereas k is exactly what you see. So the signs will not change whenever you're talking about the k. Then what you're going to do for step 4 is you're going to graph the 5 translated key points. So you're going to graph the points from your last table that you have created. Your final table. All right, so I know that what I just talked about up here can be kind of confusing. So let's go ahead and start from the very beginning. From the very beginning, we have y is equal to 3 times 2x, or 3 times the sine of 2x plus 1. So step number 1 says, let's go ahead and identify our a, b, h, and k. So the first thing I'm going to actually do is I'm going to rewrite this equation, because based on this equation, it's very difficult to see what your h value is. So I'm going to rewrite this problem as y equals 3 times the sine of 2 times x minus 0 plus 1. Now, plus 1 is not located inside of the parentheses, so that indicates that that's going to be my k value. So my a value is equal to 3, my b value is equal to 2, my h value is equal to 0, and my k value is equal to 1. So I'm going to identify all of those pieces of information from the very beginning. A, B, H, and K. The next thing I'm going to do is I'm going to identify my amplitude. My amplitude is typically what your A value is, and so my amplitude in this case is going to be 3. My period, I'm going to use 2 pi divided by B, so that's going to be 2 pi divided by my B value, which is 2. 2 pi divided by 2, the 2's cancel out, and I'm left with pi. Your midline, or your axis, is going to be y equals k, and in this case, it's going to be y equals 1. And you get that from y equals k. So since our k value is 1, my midline is going to be y equals 1. Then my 5 key points of y equals 3 times the sine of 2x. This is the same exact equation, only without h and k. So this is an equation without h and k. So what we're going to do is we're going to focus on y equals 3 times the sine of 2x, and then we're going to add in our h and k second. So I know that this is y equals 3 times the sine of 2x. So I know this is sine, so sine always starts at 0, 0. So that's sine. Sine is 0 up, 0 down, 0. That is my pattern. I'm working with 0 up, 0 down, 0. And in order for me to find my x values, I'm going to take 1/4 and I'm going to multiply it by my period, which is pi. Then I'm going to take 1/2 and multiply it by my period, which is pi. Then 3/4 times pi, and then 1 times pi. So I have pi over 4, pi over 2, 3 pi over 4, and then 1 pi. With respect to my y values are always based on my amplitude. And my amplitude represents my maximum value and the opposite of my amplitude represents my minimum value. So with sine, we're going to go 0 up to 3, back to 0, then down to -3, and then back up to 0. Now I'm not going to plot these points. These points are going to help me with figuring out what the translation value is going to be. So my translation vector is this. My h value is 0 and my k value is 1. So this represents my hk. That's your translation vector. And what this means, and I need you guys to make sure that you write this down because this is going to help you when it comes to writing equations based on words. This means that all x values remain the same. So I'm going to write all x values will remain the same. Which means, in other words, that there is no horizontal shift. The 1 in the y position means that you are going to add 1 to all y values. And adding 1 to all y values means that you are going to have a vertical shift 1 unit up. So it's going to be a vertical shift 1 unit up. So based on this quote-unquote parent function, I guess you would call it, we're going to take whatever this graph was originally and shift it up 1 unit. So now in order for you to come up with your new set of values, we're going to keep all of our x values the same. So that's going to be 0, pi over 4, pi over 2, 3 pi over 4, and pi. But now I'm going to add 1 to all my y values. So 0 plus 1 is 1, 3 plus 1 is 4, 0 plus 1 is 1, -3 plus 1 is -2, and 0 plus 1 is 1. This last table, or your final table, are the points that you're going to graph. So your graph is going to be based on your final table. So now, in order for me to figure out what I want to make my increments go by, I noticed that I have a pi over 4 and nothing really changed. I'm still working with pi over 4. So what I'm going to do is I'm going to make every tick mark a pi over 4. So I'm going to make my first line pi over 4, and then every tick mark after that is going to be adding another pi over 4. So the next one is 2 pi's over 4. 2 over 4 is 1/2, so that's why it's going to be pi over 2. Then 3 pi's over 4, and then 4 pi's over 4. 4 over 4 is 1 pi. Then 5 pi's over 4. Then 6 pi's over 4, which is 3 pi's over 2. So that was 5 pi's over 4, 6 pi's over 4. Now here's 7 pi over 4. And 8 over 4 is 2 pi. And then the next one is 9 pi over 4. So that's how I was able to fill out my x-axes. That is on the positive side. My negative side is just going to be a reflection. So the closest thing to the y-axis is pi over 4, so this is negative pi over 4. Then the next one's going to be negative pi over 2. Then we have negative 3 pi over 4. So that is labeling my axes. Since my maximum value is going to be 4 and my minimum value is going to be -2, I'm just going to go by ones. So here's 1, 2, 3, 4. This is going to be 4. And 1, 2. Down here is -2. And then the next thing I'm going to graph, even though this was one of the last things that we graphed in the last video, it's going to be my first thing that I'm going to graph. And that's going to be my axes. And my axes is y equals k. And in this case, it's going to be y equals 1. So I'm going to graph that next. And that's because it's going to give me a visual as to where my new quote-unquote x-axis is going to be. It's going to be our axes. And that's going to be located, like I said, at y equals 1. So I'm going to draw using my highlighter, or you can use whatever color that you have, a dashed horizontal line. And that represents my axes. So now I'm going to plot these points down here, and I'm going to start with 0, 1. Then I'm going to go to pi over 4, 4, pi over 2, 1, 3 pi over 4 down to negative 2, pi up to 1. And I'm going to repeat this pattern over and over again. So I went down, up, back to like your 0, but this is going to be 1. Then I'm going to go up to 4, and then back to 1, then down to negative 2, then back to 1, then up to 4. And then repeating on this pattern on the other side, looks like I'm going to be traveling down. So this is going to go down to negative 2, then back up to 1, and then back up to 4. I know that with my end behavior, I've reached my maximum point, so I'm going to start off with an arrow pointing down. So I'm just going to draw a smooth curve going through all of the points. I've reached a maximum point up here, so I'm going to make sure that my arrow is pointing down. And that is how you graph using a translation. So now I'm going to flip the page, and I want you guys, I'm going to have you guys do all of the even problems as your turns, and I'm going to do all of the odd problems for you. So for the next problem, I would like you to please go ahead and do, I'm going to do example number 2 for you, and then I want you to go ahead and do, hold on, let me get myself all situated here. Hold on just a second. Sorry about that. I'm going to have you guys do example number 2. I'm going to do example number 3, and then you're going to do example number 4, using the same exact format as to what we did last time. So I'm going to start off with example number 3. So in the next one, here's example number 3. The first thing that I'm going to do is I'm going to identify my A, B, H, and K. And in this problem, A is equal to 2. B is equal to 2. My H value is going to be the opposite of what I see, so that's going to be pi over 4. And my K value is going to be equal to 2. So now based on this information, I'm going to identify my amplitude. My amplitude is my A value, and that's going to be 2. My period is 2 pi divided by B, and my B value is 2. So it's 2 pi divided by 2. The 2's cancel out, and I'm left with pi. So my period is pi. The midline is y equals k, so I'm going to write y equals 2. And I get that value from the k value. Then I'm going to write the key points of y equals 2 times the cosine of 2 times x. I rewrote the original equation without h and k. Then I'm going to come up with my table of values. So my table of values is going to be based on this equation right here. So since this is cosine, I know that I'm going to start off with 0 and then my amplitude. So I always start up, 0 up, and I'm going to start at 0, 2 in this problem. And in order for me to come up with the rest of my x values, I'm going to take 1/4 and multiply it by my period. So that's 1/4 times pi, 1/2 times pi, 3/4 times pi, and then 1 times pi. 1/4, 1/2, 3/4, and 1. And this is going to be pi over 4, then pi over 2, then 3 pi over 4, and then pi. So now I'm going to write out my y values for cosine. So cosine starts up, so it goes up 0, down 0, up. So up at 2, then back to 0, then down to negative 2, then back to 0, and then up at 2. My translation vector is going to be hk, and my h value is pi over 4, and my k value is 2. So what this means is that I'm going to add pi over 4 to all x values, which means that I'm going to have a horizontal shift pi units over 4, so pi over 4 units, excuse me, right. And that's because our h value is positive. So it's going to be a horizontal shift, pi over 4 units to the right. For 2, we're going to add 2 to all y values. And that's because this means a vertical shift 2 units up. So now I'm going to add pi over 4 to all of my x values. So I'm going to take 0 plus pi over 4. Then I'm going to write pi over 4 plus pi over 4. Then I have pi over 2 plus pi over 4. Then I have 3 pi over 4 plus pi over 4. Then I have pi plus pi over 4. So all I'm doing here is I'm adding pi over 4 to every single x value. So 0 plus pi over 4 is going to be pi over 4. Pi over 4 plus pi over 4 is 2 pi over 4. 2 pi over 4 is pi over 2. Then pi over 2 plus pi over 4. Pi over 2, I can rewrite that as 2 pi over 4 plus another pi over 4, and that's going to be 3 pi over 4. Then 3 pi over 4 plus pi over 4 is 4 pi over 4, and 4 pi over 4 is equal to pi. Then I have pi plus pi over 4, so that's 4 pi over 4 plus pi over 4, which is 5 pi over 4. So that's what I did here. There does exist a shortcut in your calculator, and you're more than welcome to use that shortcut, but that is essentially how you come up with all of your x values. Your y values are going to be a little bit easier. I'm simply going to add 2 to all of my y values. 2 plus 2 is 4. 0 plus 2 is 2. Negative 2 plus 2 is 0. 0 plus 2 is 2, and 2 plus 2 is 4. These are the ordered pairs that we are going to graph. All right, so now let's go ahead and figure out what our axes is going to be. Since we were talking about going by pi's over 4, I would strongly recommend that you would go by pi's over 4. Obviously, you can make it whatever you want it to be, but I think pi over 4 might be the best approach. So I'm going to make this pi over 4, then this is going to be pi over 2, then 3 pi over 4, and then pi. And then 5 pi over 4, then 6 pi over 4, which is 3 pi over 2, then 7 pi over 4, then 8 pi over 4, which is 2 pi, and then 9 pi over 4. So I'm just making all of my large tick marks go by pi's over 4. Then I have negative pi over 4, negative pi over 2, and then negative 3 pi over 4. Because my maximum value is going to be 4, I'm just going to go by ones. So I have 1, 2, 3, 4. So here's where 4 is. And I also need to know where 2 is, and that's going to be right here. And then obviously we know where 0 is. And then next, even though it was the last thing that we did in our last lesson, now we're going to be graphing it first because it's going to be very important for us to know where our midline is actually located. So I'm going to draw in our midline. All right, so now let's go ahead and plot the points. So I have pi over 4, so I'm just going to be plotting these points. So I have pi over 4 up to 4. Then I have pi over 2 going to 2. Then 3 pi over 4 down to 0. Then I have pi going back up to 2. And then 5 pi over 4 going up to 4. And I'm just going to repeat this process. So I'm going to go back down to 2, down to 0, and back up to 2, up to 4. And so that's my pattern being repeated on the positive side of the graph. Over here, I'm going to go back down to 2, down to 0, back up to 2, and then back up to 4. Now I'm going to draw a really smooth curve, making sure I pay very close attention to my end behavior. And I'm going to draw a very smooth curve going through all of these points. And that is your graph. So what I would like you to please do is please go ahead and do the even examples. That is example number 2 and example number 4 on your own. And when you are finished with example number 2 and example on your number 4 on your own, then I'm going to go ahead and show you the examples, or show you the answers for those examples, and hopefully you did a really good job. So go ahead and pause the video, and when you're finished with doing that, then go ahead and restart it. All right, let's go ahead and show you the answers. So here is the answer for example number 2. For example number 2, you should have ended up with pi being your period, y equals 0 is your midline. When it comes to adding pi over 4 to, you're going to be adding 3 pi to all your x values, and you're going to be, so that's what I did here. I just added 3 pi to every single x value, so that's what you see down here. I just changed 3 pi to have a common denominator with all of the other denominators that were given to you. And then I chose to make my scale go by pi over 2. You could have made it go by pi over 4, whatever floats your boat, that's perfectly fine. So maybe your graph might be a little bit more expanded than mine, and that's perfectly fine. But that is the answer for example number 2. All right, here's the answer for example number 4. Let me get it centered for you guys. Here we go. This one was a little bit different when it comes to your period. In order to come up with your period, you're dividing by a half, and in order to divide by a half, you have to multiply by the reciprocal. And so I multiplied by 2 over 1, and that's how I got 4 pi to be my period. So I'll zoom it back out so you can see the answer again. The nice thing about adding 4 pi when your x values already started off being pi is that this is actually not that bad. I chose to make my scale go by pi's because I thought that that would be easiest. Typically, whatever this value is, this x value that is next door to 0 in your first table, typically that represents the best scale, or what you should go by. But hopefully you got both of these answers correct, and if you didn't, please feel free to email me, but that is the end of today's lesson. If you have any questions, like I said, email me. Otherwise, I hope you have a wonderful day.